In the previous lesson, we looked at the graph of y is equal to 2x plus 1. To graph it, we noted that, well, the slope is 2 and the y-intercept is 1. So we put the y-intercept at 1 and then move over 1 and up 2. We get a second point, and the line is simply the equation that goes between these 2 points. So this is what it means to be y is equal to 2x plus 1. But what does y is greater than or equal to x plus 1 mean? What I'm going to do is choose some points in the xy plane and see if these points make this inequality true. So let's start with, how about this point here, which was 1, 3. So I'm going to take 1, 3. Note that x is 1 and y is 3. And if I put that information into this equation, does it make it a true statement? So let's see. I put 3 in place of y. I put 1 in place of x. And I get 3 is greater than or equal to 3, which is true. What this means is 1, 3 is actually part of my solution. This should not be a surprise. The inequality y is greater than or equal to 2x plus 1 means, well, I already know equals means on the line itself. So any point that's on this line, if I put it into this inequality, is going to make it a true statement. So that's good. That gives me part of the answer. But there's going to be more. What it's going to break down to is it's either going to be all of the points that are on this side of the line or on the other side of the line. So let's choose a point that is not on the line. I'm going to choose the point 0, 5. I'm going to plug that information into this inequality and see if it makes it true. So let's try that. So 0, 5. So that is x is equal to 0 and y is equal to 5. If I put that into the inequality, I get 5 is greater than or equal to 2 times 0 plus 1. So is that a true statement? And this is 5 is greater than or equal to 1, and this is in fact true. So the point located right here makes this a true statement. So this should be included in my answer. So I could, let's say, put a blue dot right here. It'll turn out that once you choose a point on one side of your line and it makes this inequality true, every point over here has to work. So I'm just going to try this with one other point. So how about -6, 2? Does that point work? So let's see. That's x is -6, y is 2. So I get 2 is greater than or equal to 2 times -6 plus 1. Or 2 is greater than or equal to, that's -12 plus 1. Or 2 is greater than or equal to -11. Okay, that's clearly a true statement. So, okay, I get this point here as well, -6, 2. I mean, that's enough for me to say, okay, everything on this side of the line has to be an answer. So I'm just going to sort of shade that in and say, this is my solution to the inequality. It's not just the line. It's every single point that's on this side of the line too. Just to see that other points on the other side of the line don't work, I'm going to choose, let's say the point 6, 0. So I'll look at that one. So what about 6, 0? It should be that this makes the inequality false. So that's x is 6 and y is 0. 0 I put in place of y. I put 6 in place of x. I get 0 is greater than or equal to 12 plus 1, or 0 is greater than or equal to 13, and clearly this is false. So every point that you choose over here is going to make this inequality a false statement. So I just don't shade it. So the takeaway here is, if you're solving this type of linear inequality, start by graphing the line. Because there's an equal sign here, I want to include all of these points. But then afterwards, you want to shade in the side of the line where at least one of the points works. So let's try this idea on another example. So here we have the inequality, y is less than -x plus 4. Now I notice there's no equal sign in this inequality, What this will mean is, if we graph the line y is equal to negative x plus 4, I just want to not include those points. So I'm going to start by graphing y is equal to negative x plus 4. I'll note that the slope is negative 1, or negative 1 over 1, and the y-intercept is 4. So I'll put 4 on the y-axis. The slope is negative 1 over 1, which means I go down 1 and over 1. So all of these points are on my line. So instead of just drawing a solid line that goes between these points, what I'm going to do is just try to do a dashed line between the values that I just plotted. So instead of having this like solid line that goes between all of the points, I sort of just did a dashed or dotted line to represent, okay, this is my barrier and I'm not including any of those points that are not on the line. And the reason I'm doing that is because there's no equal sign on my inequality. The second part of this question is to choose a point on either side of the line. If the point works, it means every point on this side of the line will work. If it doesn't work, it means the other side of the line has to be where all the points make this inequality true. So let's see, I'm going to choose the point, let's say 5, 5. So that's obviously 5 for x and 5 for y. I'm going to put that into my inequality and see what happens. So that is 5 is less than negative 5 plus 4. Or 5 is less than negative 1. That's false. So the point that I chose here does not make the inequality true. So I know I don't want to shade this side of the line. It's got to be that all of these points are the ones that make the inequality true. But just to double check this, I'm going to choose, how about the point 0, 0? I want to put this into my inequality and see if it makes this thing a true statement. It definitely should, but just to be careful. So that is x is 0 and y is 0. I get 0 is less than negative 0 plus 4. Or 0 is less than, well, negative 0 is just 0. And 0 plus 4 is 4. This is a true statement. So it, in fact, does work for this point here. I can now say, all right, the solution is going to be all of these points, the ones that are on this side of the line, and that would be the answer to this question.